The functions f and g are given. Evaluate f circle g and find its domain. So this function f circle g, so it will be in terms of x is just f of gx. So pretty much we plug in g into f. So f of this g is given 4 over x. Since we are asked to find domain as well, let's keep track of that. 4 over x, we can't have 0 on the bottom, and we get 0 when x equals 0, so x can be equal to 0. Okay, so f of g is 4 over x. Now f of input is equal to 2 over input minus 1. So we have fx equals 2 over x minus 1. That means f of anything, okay, this input equals 2 over that input minus 1. So in our case, that input is 4 over x. So f of input is equal to 2 over input minus 1. And we still have this. We'll take care of that in a moment. Now let's simplify the bottom. We know that 4 over x minus 1. We need to multiply by x over x to make common denominator. So x, 4 minus x. So when we combine these two fractions on the bottom, we get 4 minus x over x. Now remember, this is the initial division. So we keep, change, flip. So 2 times x over 4 minus x, and we already have x not being to 0. That's the restriction coming from g. 2 times means 2x over 4 minus x. That's the function f circle g. Okay, so this is the composition of two functions and its domain. Now x can't be equal to 0. That's coming from g, and this fraction, since this is a fraction, we can't have 0 on the bottom. So 4 minus x becomes 0 when x equals 4. So x can't be equal to 4 as well. So this is the domain, but we want to write in interval notation all real numbers except these two. So we need to avoid 0 and 4. So that's the part of answer. And domain of this composition, okay, this composite function is negative infinity through 0, union 0 through 4, union 4 through infinity. Or this is same as saying all real numbers x such that x can't be equal to 0 and 4. Okay, this is set builder notation. This is in interval notation, final.